Okay, so you now know about attention, you know about encoder, decoder models. In assignment 4, you will actually train one. And you know what machine translation is. A sentence in one language, like Afrikaans, and then you get a sentence out in your target language, like English, and you're trying to translate from the one to the other. Okay. Now, what I skipped in the last lecture, and is the only technical thing I will do today, is tell you how to actually evaluate a machine translation system. So in assignment 4, you will go and build a machine translation system. So it takes Afrikaans in and pops English out. Okay. Now, after training your model on the training set, you want to evaluate it. So you pass in some sentences that the model didn't see during training. You pass in some sentences and you get output from your model. And now you want to know how good is the output from my model. Okay, so you get a bunch of words out. Okay, and you have the ground truth. You know what was actually in the real translation. So someone has actually translated this. You know what should come out. You have the output from your model, the predicted output, and you want to know how good your model is. Does that make sense? Not, David, I've heard you spill coffee all the time, and I just saw it live. It was so close. Anyway, new laptop for Katerina, it would have been great. Okay, wait, stop. We want to evaluate the machine translation system. So we're getting a sentence out, and we know what the sentence should be that comes out. Does that make sense? Tell me of one way to evaluate this without looking at the slide. So I've got two sequences. They might be of different durations, different number of words coming out. Tell me how to evaluate it. Let's look at this stupid example here. So you can look at the slide now, but ignore everything on it. Apart from the example here. So the input to the model was the cat sit op die mat. Okay. The model outputs the cat sat on. That's the output, the predicted output of the model. Your ground truth label in your validation set is the cat sat on the mat. So this is the correct translation. This is the prediction. The input was the cat sit op die mat. Okay. Now we've got a predicted sequence here. We've got this sequence here. Tell me, how can I get a number, one metric, that tells me how good a sentence this one is compared to my ground truth? Yes?
It's not the right answer, but we could do the edit distance.
Yes, that was what I was looking for exactly. So what Katerina says is you take this sentence, you align it to this sentence, and you check how many insertions do I make, how many deletions do I make, and how many substitutions do I make. And in speech recognition, that's actually what you would do. And you would calculate something called the word error rate, which is really just the proportion of insertions, deletions, and substitutions as a fraction of the number of words coming out, after the number of true words. So you could do that exactly, and that would you could actually do that with machine translation as well and get a word error rate. Turns out what people actually use is this thing called BLEU. Okay, it stands for something. Bilingual, I don't know, evaluation, I can't remember. Okay, there's many people that use this stuff and can't remember what it stands for, but this is the metric that they actually use for machine translation, and it's slightly better for machine translation than word error rate for some reasons, which I'll touch on right at the end. Okay, but you can use something like edit distance and get the error rate as well. But this is how BLEU works. I'll just say BLEU because that's how some people say it, and I'm one of them. Okay, it sounds dumb, but okay, let's just talk of BLEU. So you've got your predicted translation y hat coming out of the model. You've got your reference y, and I want to know how good it is. What I'll do is I'll ramble through how BLEU works, and then I'll do an example which will then show you exactly how it works. So what BLEU asks is, in my prediction y hat, I'm going to compare that to y, and what I'm going to do is I'm going to calculate this little Pn. Pn is the precision of n-grams of order n. Okay, this means that out of the n-grams, let's do bigrams. out of the bigrams, all the bigrams that I have in y hat, how many of those bigrams occur in y, in my ground truth? Okay, so out of the bigrams in y hat, how many of them occur in y? Okay, and what you do is you calculate this Pn. So P1 would be unigram, P2 would be bigram, P3 would be trigram, P4 would be 4gram, 5gram, and 6, and so on. They normally specify a length, so something like 5. So you do 5 grams. And what you do is you calculate 5 gram, 4 gram, trigram, bigram, unigram, precision. Okay? So you get 5 numbers, literally comparing y hat to y, and you're asking how many of the stuff of the n-grams in y hat occurs in y, and you keep track of them. Okay, you get all those numbers. I'll do an example in a second, and then what you do is you plug them all into this monstrosity here. Okay, this is the equation for BLEU. Okay, I'll run through it and then I'll run through it again. Okay, but what it does is, so here you've got your unigram times bigram times trigram precisions. You multiply them all together, so it's like a geometric mean. So you're multiplying all those numbers together. You're multiplying them with this, you're taking to the power of this monstrosity here, I'll say y now, and then you take that product of all the stuff and you multiply it with this monstrosity in front. Okay? Now each of the monstrosities in this equation have a purpose. Okay? First of all, if y hat and y matches exactly, and you have the same, which means you will have the same n-grams of all orders in the two things, then your BLEU would be 1. You can go and work it out, because you will have 1 times 1 times 1 times 1 to the power of something, but that's just 1. Okay, and then the lengths will be the same, so you've got 1 minus 1, 0. So you're taking the exponential of 0, which is 1. 1 times 1 is 1. Okay, cool. That's great. 1 mathematics. Okay, so if the reference y and the prediction y hat matches exactly, then my BLEU is 1. Okay? This term here, that little to the power of thing, what the fudge does that do? That's described in this bullet here. So it's normally easier to match unigrams than it is to match bigrams. It's easier to match bigrams than it is to match trigrams, and we'll see that in the example. So what that term does is it puts a larger weight on longer n-grams. So if I'm counting 5 grams more than I am counting a unigram. Okay, so that's what this thing does here. It puts that weight on there. That's what that does. And then the other thing that happens is, very often if you just produce short outputs, right, then all my n-grams in my little short output, actually, because I'm calculating a precision, actually occurs in my reference y. So you get an unwantedly good score for short outputs, which is not what you want. So this monstrosity here at the front, it penalizes sentences where the length of your prediction and the length of your actual output differs a lot. Okay, or stated differently, it puts a length penalty on your output so that longer sequences gets a nicer score. The little example here is if your output is AB, but your ground truth is A, B, C, D, E. AB, we'll see an example now. You actually have A occurs here, B occurs here, so your unigram precision is 1. AB also occurs here, AB, so your bigram decision is also 1. And you would have got a BLEU of 1, which is obviously wrong, right? This output is way shorter than this one. But now you have this penalty in front, this little penalty, let me make it in red, this penalty term here in front, and that then means that you weigh BLEU with the 0.14 because the test and the length are so different. Okay, let's just do an example because none of that made sense, right? Okay, wait. The only thing I will do in the example is actually show you how to calculate these precisions. Okay, but once you have the precisions, you stick them into this equation and then you get BLEU out and life is wonderful and you have a score and there's no load shedding. Okay, I mean if your BLEU is high, if your BLEU is low, then life is still horrible and there's still load shedding. Okay, so let's just quickly do an example and then we're done with the whole course, more or less. Okay, so here I've got my output for my model is the cat sat on, and the ground truth was the cat sat on the mat. Okay, and we're just going to calculate the positions for these different things. What we will do is we will calculate all the n-grams up to 4. Okay, so this is the longest n-gram that we consider. Okay. And when you're calculating BLEU, normally you use some toolkit, and in that toolkit they've already decided this is the max n-gram count. So this is the longest n-gram for matching. Cool. Where will we start? Okay, let's start at the back and then move forward. So let's start with P4, the precision of the 4 grams. Okay. Who can tell me what P4 is in this case? So I can't actually do it in my head. Okay, so let's just write it out. So to do this, you need to know what are the 4 grams that I have in y hat. Tell me the 2 4 grams that I have in y hat.
The cat set.
The cat set. Okay, Matt, now you stay quiet. Thank you for your contribution. Okay, cool. Someone else, what's the other one?
Cat set.
Okay, wonderful. Thanks, Katarina and Reinhard. It was beautiful. Okay. The cat.
In Seychelles, they call a Kit Kat a cat cat.
What?
It's a thing.
In the Seychelles. Okay, sorry, my holidays are a lot more boring. Okay, anyway.
Cat cat.
Sounds like you're cursing. Okay, cool. Tell me the 4 grams in Y. My actual output. This is the target 4 grams. This is the stuff I want. Just shoot. Carla. The cat sat on. Thank you. I don't know. Was that Willem? The cat sat on. Cool. Reinhard, you next.
Cat sat on the.
Cat sat on the. Carla, you're next.
Sat on the mat.
Sat on the mat. On the mat. Matt, you're next. Oh, come on, eyes on the prize. Okay, there isn't another 4 gram. Okay, so
That's what are you asking?
there isn't another 4 gram. Okay, cool. What's P4? So P4, out of the 4 grams in my prediction, how many of them occur in the ground truth?
0.
So 0, that's right. Okay, let's just do it like this. What's at the bottom? Out of the number of 4 grams, how many 4 grams are there? There's 2. Okay. So out of these 2, how many occur here? 0. So P4 is 0. Excellent. Cool. Let's do a more interesting one. Can you just stare at it and tell me what P3 is? Ryan's guessing 1/3. Why? Okay, why 3? Let's just go with, so
Because there would be 3 trigrams at the bottom.
what are the 3 trigrams?
The cat sat and cat sat on. And
Okay.
the only thing that occurs in the the true case is cat sat on.
Okay, did you all get that? So there are 3 trigrams in Y hat. The cat sat, and cat sat on. That's 3. Okay, cool. And Renat, I can't see this. Which one is the... Okay, cat sat on is the only one that occur at the top here. Cat sat on is the only trigram that actually correctly occurs at the top there. Excellent. I think that's right. Okay, cool. Okay, so P3, the order here is completely messed up. Okay, cool. But we have P4, we have P3, we need P2. P2 gets a little bit crazy. Okay, but let's... I'll write it out. So bigrams in Y hat, I always need to write it out. Bigrams in Y hat is the cat cat, cat sat, sat on, Reinhard, shut up, but it is the right answer as well. Okay, so you said 3/4, that is completely correct. Okay, I mean, I don't have to write out all of them, right? The cat sat, I'll miss, sat on the mat. Okay, which ones are right? So let's just check this. The cat occurs. Well done. Okay, and then cat, wrong. Okay, that one is wrong. Okay, cool. Cat sat, right. Sat on, right. 3/4. Wonderful. So P2 is 3/4. The last one is slightly tricky, so I just want you to make sure that you get this. Okay, cool. So P1, the slide is getting disgusting, but anyway, let's just do P1 here. It's relatively easy because the unigrams are just the words, right? Okay. So what do you think P1 is? Okay. Okay, let's start with the line at the bottom, of the number at the bottom. What's that called? The denominator.
What happens with the double?
Okay.
No, it's cat is unique.
Okay, cool. The first question that Katrina and you asked is, do you count the number of unique n-gram types, or do you actually count all the n-grams, right? Because the problem is here you have the cat, sat, and on. One strategy is you then map that to just the cat, sat, on. But actually that's not what you do. You count the n-gram tokens in your output. Okay, so the number at the bottom here would then be, you count the n-gram tokens. What's the number at the bottom? You've got two okay, someone said 3. I do not know where you okay. You've got two options. It's 4 or 5. Who votes for 5? We're counting tokens. Who votes for 5? Who votes for 4? We're counting tokens.
Okay, so it's the occurrence is not the
Types.
vocab.
Yes. Okay, cool. Who's not voting for 5 now? Leave. Okay, cool. Okay, 5 is the right answer. Now it gets slightly tricky. Okay, cool. What's the number at the top?
I'll do 5 again.
Okay, that's the one option. Cool. Okay, so let me tell you're wrong. Okay, but you need to know the extra rule in order to know that you're wrong. So what you did isn't unreasonable. So what Willem did was the following. He said, out of these 5 words, the occurs here, cat occurs here, cat occurs here, sat occurs here, and on occurs here as well. So I want to write the 5 there. Okay? But what they actually do when they're calculating BLEU, and this is the only little tricky part, is that you're maxed out by the number of, okay, I'll say it and then I'll explain it again. You can only get credit for repetitions here up to the maximum number that's in your ground truth. Okay, does that make sense?
Yeah.
So you get a point for this one, well done, because it occurs. Then you get a point for this one, well done, because it occurs. You can't get a point for this one because you've already used this cat. Okay, so this has been used, this has been used. Sat, you get a point because it occurs, and then on, you get a point because it occurs. So you have 4 out of 5. That's how they calculate the unigram counts. Or actually for any of the n-grams. Any repetitions, you can only get credit up to the maximum number that you have in your ground truth. In other words, if we were in a setting where we had your label here, the ground truth was the cat sat on the mat, then you would get credit for this cat because you can match this one to this one and that one to that one, and that's fine. So you're capped or clipped by the number of occurrences in your ground truth, and you can't get credit for all of them. Okay, does that make sense? If we had the cat, you need to keep track here. The cat sat on, and we had the cat sat on the mat, then you would get credit for this cat and this cat, but not that one because you've already used up your 2 at the top. Okay, and that's it. Let me just undo this because I mean I would have no idea next year what fudge I did. Yeah, okay, cool. So you calculate all these little precisions and then you stick them into this formula. Okay. Just to recap very quickly what I said before, longer things count more, right? Because you're taking to the power of, and these numbers are smaller than 0. So for a fixed value here, this will increase with a larger n. So you get more points for matching larger n-grams. And in the example, you already saw that matching a 4-gram is really difficult, right? Because you're matching all these 4 things. Okay, cool. So that's the one thing. And then shorter output. If you just did this, shorter output would get a lot of credit because you could just output the, and then you would have a P1 of 1. Okay, and then you've won the whole competition. No, so you actually penalize shorter sequences with that term in front. Okay. The last thing I wanted to say about BLEU is that in practice there's often more than one reference, and this is because when I ask you to translate a sentence from Afrikaans into English or from isiXhosa into English, if you ask 5 people, they might actually give you 5 slightly different translations, right? Because there are often actually legit more than one way to translate the sentence. Okay, so often what you do is you actually don't have a single Y, you actually have maybe more than one Y. So you ask 5 people to annotate how would you translate this, and then what you would do is for your Y hat you would get credit for an n-gram if it occurs in anyone's translation. Okay, and this is why this is slightly better than something like word error rate where you would just have a match 1-to-1. I should say that BLEU is a really crappy metric, but it is the best metric that exists. Okay, so it's a little bit like democracy. It's a really bad system, but it's the best one out of all the crap that exists. Okay, so BLEU, if you go to an NLP conference now, I almost guarantee you there will be a paper proposing another metric for machine translation. There's one every year, okay? But BLEU has stuck, and it's kind of okay. It's good because everyone uses it, and so it's not perfect. It doesn't actually match always how humans would actually score the sentences, but it is, as an objective metric, something that a lot of people use. Okay, does that make sense? Happiness? So use BLEU for your assignment 4.